Welcome back, my fellow intellectuals. This is the Universal Data Boy, or you might as well call me the A+ ambassador. So we go on still in physics on dimensional analysis. Now we go on to question 2. So if you want your question to be answered, you can send it to 0978957975, and it can feature in the next videos, of course. So now we go to 2. So 2 has A and B. So 2 reads a shape that covers an area A has a uniform height h. A shape that covers an area A and has a uniform height h has a volume V is equal to AH. Show that V equal to AH is dimensionally correct. So now to show it's dimensionally correct, we start with, let's just start with this VA is equal to H. So now the dimensions of volume are basically length to the power 3. So that's the dimensions of length, or the units of length. So now you can put this, let's put this, let's say put it there, but even inside is all the same. The dimensions of area are the dimensions of length squared. The dimensions of h are the dimensions of length squared. So the dimensions of length to the power 1. It's all the same, just the dimensions of length. So now when you multiply these two, you're going to get the dimensions of length to the power 3 times the dimensions of length to the power 3. So now this shows that this is dimensionally correct, because what's on this side is equal to what's on this side. So dimensions of volume are the dimensions of length to the power 3, and we have things like centimeters cubic, meters cubic. The dimensions of area are the dimensions of length to the power 2. We have got centimeters to the power 2, meters squared, and things like that. And then for the dimensions of length, we have got length, height. This is centimeters, meters. You know how that goes. So that's it for A, as simple as that. And then for B, show that the volume of a cylinder and a rectangular box can be written in the form V is equal to AH, identifying A in each case. So now we have got a cylinder, right? A cylinder looks something like this. Cylinder looks something. Forgive my drawings, eh? I'm not an artist. I'm a scientist though. So now we have got this. This is a cylinder. Yeah, it looks something like that. And this is the area. Or this is the radius, sorry. This is the radius. So now to find the volume of the cylinder, we say volume is equal to pi r squared times height. Well, this is the height. This is the height. So now the surface area, this surface area of the cylinder or any circular object is given by area equal to pi r squared. So definitely when we place this there, V is going to be equal to AH. So now here we have shown that the volume of the cylinder can be written in this form. So now let's go to the volume of the rectangular box, and then remember you're being told to identify A in each case. So now here you have identified the A to say it's pi r squared. That's the A for a cylinder, and you don't necessarily have to draw this. I just wanted to show you so that at least you can get a basic understanding. So now a rectangular box, it must look something like this. This is a box. I'm trying as much as possible to draw it in 3D. Yeah, so these are at the back, this face is at the back, this face is this side, this face is this side, this face is up, this face is down. So now we have our, okay, let's say this is our height, right? And then this is our, what do you call this? So we have got, so we can say this is our width. Okay, let's just give it WA. This is our width, then this is our width, B. So now here the volume is equal to W times B times H. That's how you can find the volume. And then the volume, the surface area this area here can be given by W times B. That's the area there. So now this can be replaced by that, whereby I saying the volume is equal to A times H, which is just equal to V is equal to AH. So now you have shown that even the volume of a box can be expressed as V is equal to AH. Now in this case of a cylinder, so we have a cylinder there, then we have a box. So here show that the area of a cylinder is equal to pi r squared. Then here show that the area in terms of the box, is equal to WB, which is the same as W times B basically. So you can, these are basically arbitrary, meaning that you can choose, you can say this is A and this is B, then here you have A times B, but then you keep the H the same, so at least when you bring in your volume, you're going to actually have the same answer. So that's it for me. Bye bye. Remember to subscribe to this channel, also share with a friend who might find this very, very helpful. And then remember, together we can. It's not as hard as you think it is, it's only as hard as you think it is.